All right, hello travelers. Welcome to Reach the World STEM Week. For over 20 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens using virtual exchange. My name is Tim, and as part of Reach the World's efforts to support educators and families during the COVID-19 pandemic, we are using the power of Zoom to share free live stream events with members of our global community. You can find a complete listing of upcoming events and much more on our website at athome.reachtheworld.org. Today, we're welcoming not one, but two special guests to show and tell. Oliver Plunkett is the CEO of Ocean Infinity, a cutting-edge underwater exploration company. Joining Ollie is Dan Hook, who is the Managing Director of Armada, which is Ocean Infinity's fleet of low-emission marine robots. If you followed Reach the World's exchange with the Weddell Sea Expedition last winter, you may remember that it was Ocean Infinity's incredible autonomous underwater vehicles, or AUVs, that traveled beneath the Antarctic pack ice and made it possible to survey the seabed in one of the most remote, isolated corners of our planet. Today, Ollie and Dan are going to talk about the future of marine robotics. But first, to our live stream viewers, please be sure to let us know you're here in the chat and share any questions you have for Ollie and Dan by typing them into the YouTube chat bar. We'll be sharing questions from our on-camera participants and questions submitted via YouTube, and we'll get to as many as we can. But without further delay, I want to turn it over to our special guests. Welcome to Show and Tell, Ollie and Dan.
Hi, everybody. So my name's Dan Hook. I live in England, so hence the slightly funny accent, which you're gradually getting used to with more of these presentations. So I'm very lucky. I've got what I think is one of the best jobs in the world. I get to work with marine robots, and I've been doing that for about 20 years. Had a lot of fun doing it, and I'm looking forward to sharing with you a few of the sort of things that these marine robots can do and talk about some of the things they're going to be able to do in the future. So I'm going to do that for a few minutes. I'll share a presentation with you, and then I'm going to hand over to my colleague Ollie, who's going to tell you a pretty cool story and an example of what some of these robots can really do. So just bear with me while I share a slide. Hopefully you will all be able to see this okay.
Yeah, looks great, Dan.
That's coming through. Hopefully that comes through full screen for you. There we go. So yeah, I'm lucky to work for a business called Ocean Infinity, and we absolutely focus on running marine robotics. So we deploy all sorts of different types of systems at sea. Some of them go under the water, some of them stay on the surface of the water. And with those systems, we do a whole range of different tasks. So one of our focuses is expanding our knowledge of what is down there. The ocean is so unexplored. There's so much still to see. And we've been using marine robots to help many of our customers and organizations around the world see what is down there in very high resolution. We'll show you some examples of what we mean by that. But marine robots do more than just explore. They also help things like the renewable energy industry. So many of you might have seen some of the offshore wind turbine or offshore wind farms that are being built all around the world. There's many of them here in Europe, and there's now some being built off of the east coast of the US. And these huge offshore wind turbines generate electricity. But before you put them in, you need to understand the seabed. And marine robots have been fundamentally important in helping do that. The technology really is cool. We're going to show you lots of examples of different systems and what they can do, and tell you just how fast it's moving as a topic, as a science, as an engineering discipline. They can also help look for oil. So the oil industry is one of the world's biggest industries, and going looking for oil at sea is a big challenge. It's such a huge expanse of ocean. So they're very involved in not only looking for it, but then once we've found it, helping produce it and make sure it's done responsibly and safely and sustainably. They also have a big role to play in defending our nations. Now, by this, I mean things like security. There's lots of things like unexploded ordnance from previous World War II particularly. There's a lot of unexploded ordnance in some areas of the sea, particularly here in Europe. And marine robots offer a way of safely going and finding those unexploded ordnance, those old bombs that got dropped, and safely removing them without putting any people in harm's way. So robots are doing a huge variety of things, helping explore, helping produce energy, helping defend countries, but also more helping us map routes where we lay cables. So we're all watching this via the internet, and the way that I'm here in England, linked to most of you there in the US, is via an internet cable, which runs along the bottom of the ocean. Marine robots help find where to put those cables and help install them. So it's a very, very wide application area. I'm going to show you a few sort of examples and talk through a little bit about what we mean by marine robots. So there are many different types. One that you might have seen a little bit on the internet and in books and on videos is what we call an ROV, a remotely operated vehicle. Now, the smallest ones of these fit in my hands. There are some very, very small systems that you can almost carry in your backpack, put over the side of your boat and maybe swim down and look at your propeller, check you haven't got ropes tangled around your rudder, do some small inspection type work. Then some of them get a bit bigger. They may be the size of a sort of small car. And those are the type that we use to go down and look at things on the seabed like cables and pipes and wrecks. And we do interesting science looking for different types of wildlife, things that have never even been seen before. And then there are some that are huge, that are bigger than my house. And they go down and produce, they can dig trenches where we lay cables. They can help recover ships. They can help repair damage that's happened on the seabed. Now, these are all connected to the surface via a tether. So somewhere there's a person on the sea surface controlling these with joysticks and screens linked to them via a cable that's about as thick as my thumb. So that's an ROV. Another type which we're going to tell you a little bit more about at a slightly higher level of technology are called autonomous underwater vehicles, or AUVs. And these are untethered. So these really are robots that go off, make their own decisions and navigate themselves without so much help from the surface. Again, there's a whole range of different sizes. Some of them are this size and one person can pick up. Some of them, like the ones we operate at Ocean Infinity, are like the size of an SUV, and you definitely can't just pick one up yourself. You need a crane. Now, these carry a whole range of different sensors. Most of them transmit noise and look for the reflections, and then from that we build maps. But they also carry cameras and lasers, and we can match all that data together and build some unbelievable images. So that's an AUV. And then the other type that I've been fortunate to spend most of my career with are robotic vessels that operate on the surface of the sea. So robot boats or robotic ships. There's an increasing number of these, and there's certainly kind of a few. When we look at all the marine robots that are out there right now, I would estimate there's probably 100 or so currently doing things at sea while we're all watching this video. There's more and more of them going to sea every year. So robotic ships vary in size again hugely. The ones that we're currently building and going to operate next year, we call our Armada vessels. The smallest of those is about 70 feet long. The middle size will be over 120 feet long, and we're even looking at one that's closer to 200 feet. So these are big robots, many hundreds of tons in weight. They can carry some huge amounts of equipment on their deck. We can launch some of the other types of robots I just showed you. So we'll be able to launch an ROV. You can just see that in this picture here on the left. And we'll be able to launch an AUV. So this is using a surface robot to deploy underwater robots. Now, it's really important that you absolutely minimize your emissions. So the team I work with have put a lot of effort into these vessels, making sure that we burn the minimum amount of fuel we possibly can. And we can even use solar panels and other things, other renewable sources of energy to completely minimize our impact. So that's the different types of robots we operate with. And I'm going to let Ollie show you some examples now and tell you a bit of a story about how they get used at sea. So over to you, Ollie.
Thank you. We do all sorts of things with our robots in the ocean, and Tim mentioned the Weddell Sea project, but one of the things we get to do is go looking for shipwrecks. And we did project last year in the middle of the South Atlantic, where we were looking for a particular shipwreck that had been sunk in the First World War, so more than 100 years ago, in a famous battle called the Battle of the Falklands. And it was a battle between the British Navy and the German Navy, who were at war back then. And the Germans had a big battle with the British near Chile, which they won, and they sunk all the British ships. And the British government were really upset about that. So they sent a fleet down to the Falkland Islands to wait for the German ships to come round. And they knew they were coming that direction. And just as the German ships came over the horizon, the British ships left from the harbour and they had a huge battle. And in the end, the British won the second battle and sunk all those German ships. So we went off to look for them, see if we could find those battleships, so that we could help tell the story and the story of what happened in the battle and the people as part of remembering and making sure that we recognise, our history and learn the lessons from it. I'm going to show you a film now, because we were very fortunate and we found the battleship that we were looking for. And we looked for it with our AUVs, which were the orange robots that Dan showed you just before. And then we went down and had a look at it with one of the ROVs, which had a video on. And I'm going to show you a video that is filmed a mile beneath the surface of the sea, looking at a shipwreck. So that ship has been there for over 100 years. And you can see the wood of the deck of that ship is still the same, like it was 100 years ago. Except now it's got a crab. And what you can see there is the damage that was done to the ship in the battle, and the guns on the side of it.
That's played.
But what is amazing about those shipwrecks is how they become a place for life. And so you saw the marine life that was growing, and you saw that little crab who made his home on the deck of that shipwreck. And it's always incredible to see how, whether they're wooden shipwrecks or like this one, a steel shipwreck, life develops where you don't think there's going to be life, because it's so dark and it's so cold. But somehow life generates and creates this incredible scene that we can see. I don't know what's next, Dan.
Sorry, okay.
Again. And then some of the work we do isn't looking for shipwrecks, but it's making maps of the seabed. And all sorts of people want maps of the seabed, whether it's the people putting a cable, or they're exploring for things, or they're putting pipes to bring energy sources back for us to use. But there's some incredible statistics about the mapping of the seabed. And the one that I like is that if you divided the ocean up into 1 kilometre squares, only something like 3% have got any data points at all. We just know nothing about the seabed because we've never been looking. Whereas there are more complete maps of the moon and Mars, where we've sent space rockets and satellites to go looking. And so what you saw there, looking at that shipwreck in the South Atlantic, almost literally nobody else in the world has ever seen that, because they've never been. And that's because until now, we haven't really had the right type of technology and the right robots to be able to go down and survive more than a mile beneath the surface of the sea.
Shall I talk about this one quickly, Ollie?
Yeah, go for it.
And back to you, jump in. So, as I said at the beginning, I've been really fortunate to have a career I'd always dreamed of, getting to work with these marine robots. As a kid, when I was at school, I used to build little radio-controlled boats and little sailing boats, and sort of dream of the chance to do it as a job. And the good news is there are lots and lots and lots of jobs out there where you can work with marine robots. There's the jobs in designing them. So sitting at computer screens, using the latest sort of computer design techniques to think up these robots and design them and simulate them and look at how we're going to build them. There's then jobs in building them. So actually assembling them in engineering workshops and laboratories. There's then one of the real fun jobs, which is driving the robots. That's one everyone enjoys. So you actually get to operate these robots, and it doesn't matter whether they're on the surface like the robotic ships, they're underwater and untethered like the AUVs, or they're underwater on a tether like the ROVs. All of them need an operator. So somewhere there is a person sitting at a screen, much like that one I've shown in the middle of this slide, actually operating it and exploring the ocean using that robot. Of course, there's the work fixing and maintaining them. These systems go out in all sorts of weather. Doesn't matter whether it's day or night, whether it's a flat sea or a storm, the system will be out there. So they do need a lot of maintenance and repair work. And then there's analyzing the data they collect. So there are lots and lots and lots of scientists and engineers all over the world that are using the data that comes from the robot to sort of make decisions, make discoveries, run experiments. So there really is hundreds and thousands of jobs that are out there if it's something that interests you. And yeah, I'm slightly biased. I've had such fun doing it. There's lots of opportunity to travel. There's lots of opportunity to be very creative, very innovative, and do new things. So for those of you that are out there thinking about what your career path could be, marine robotics are a lot of fun. So I think that's the last of the slides that we were going to show you. I think we've managed to keep roughly to time, Tim.
Yeah, that was fantastic, Daniel. Thank you so much. If you come out of screen share, we'll get a chance to dip into all of these amazing questions that we're getting, both from students who are on camera and students in the live stream. So if any of the students who are watching on the live stream have a question, please feel free to raise your hand. But I want to start with one of the questions that came in through the live stream. Actually, this is a combination of several questions. There's a lot of interest in the specifics of the marine robots themselves. How do the electronic components stay dry? Can they go inside the shipwrecks? How do you control them when they're so far away from the ship? Can you give us a little bit more detail about maybe specifically the AUVs and how some of that technology works? It seems kind of amazing.
I think they are amazing. The AUVs, they almost have their own brain. And you remember back to the picture, there was what looked like a camera at the front of it. Well, it uses that camera to know if there is something in front. So as it's sailing along, if it sees an obstacle, it knows that it has to avoid it. And it can either go around it or climb over the top of it. But it works that out for itself. So when we launch them, we tell them the area we want them to go and look at. But they broadly go off and use the mind of their own. They've got a computer brain. The components are all designed to be able to work in the ocean down to 6,000 meters. And 6,000 meters is about 4 miles beneath the surface. And there's a lot of pressure. So all of the components are specially designed. They run on batteries. so lithium batteries. So the motors are relatively straightforward, but there's a big computer brain that helps it know where it's going, where it is, which direction it should be going.
All right, fascinating. I want to jump to one of the students on the call. Julia, would you be interested in asking a question?
Sure. One of my questions was, have you ever found yourself on an expedition where one of the AUVs fails to navigate itself through different terrains and you're not able to bring it back or something? What do you do in that kind of situation?
Yeah, so yes is the answer, because sometimes they come across some situations that they don't recognize. And the biggest challenge around the technology is the piece that lets them know where they are. So if you imagine you're driving to school, you kind of know where you are because you know the roads, and maybe you've got a GPS in your car. But at the bottom of the ocean, there isn't a GPS and there is no road. So the computer, it works out how far it's traveled from its last point and then guesses that it must therefore be at the next point. Sometimes it gets it wrong. And if it gets it wrong, it says, hang on a minute, I've got it wrong, and it panics and it comes straight up to the ocean, to the surface. And we might have to drive 20 miles to go and collect it. So that definitely does happen. And we try our best to make sure it doesn't, but sometimes its brain just can't work out where it is.
Fantastic, great question, Julia. Devin, let's go to you. You have a question you want to ask Ollie or Dan?
Okay, I have a question. So you've been finding a lot of like shipwrecks. So how successful have you been finding all those shipwrecks?
So we've become quite good at it. So we've found a lot of the ones we've been looking for, and we don't always find them because sometimes you don't have enough information of where to look. One of the ones that we went looking for was that Malaysian Airlines plane that went missing 6 years ago, and we weren't successful finding that because actually it's really hard. There's a huge area of the ocean that we were looking in, and yeah, we didn't find that one. So we're quite good at it, but we haven't always found what we're looking for.
Yeah, fantastic question. There was a question on the live stream as well that sort of piggybacks off of that. When you find a shipwreck or you find something of interest on the bottom of the ocean, do you bring things up from the surface of the ocean, or do you leave it where it is, or what do you typically do?
It depends. So most of the time, if we find a shipwreck like the one that we saw in the film, we make a film of it. And I think with that one, someone will write a book and tell the story. And so actually the important thing, particularly if it's a historic shipwreck, is to record it and tell the story and share the story. Sometimes people ask us to go and find shipwrecks where they want to bring things back. We did a search for a shipwreck that was sunk in 2017. And what they wanted was to find the data recorder so they could understand why the ship had sunk. And so that one we found it, and we recovered that data recorder and brought it back to the surface.
All right, fascinating. So many great questions on the live stream chat and from our on-camera participants. We'll get to as many as we can. I want to go to Lysandra next. Lysandra, do you have a question you want to ask Ollie or Dan?
Yes, I do. Thank you. I want to ask, can the Armada withstand any temperature and depth? If not, what are its limits?
Great question.
Really sorry, Lysandra. It's my fault, not yours. My link broke up a little bit there, so I missed the question. I'm terribly sorry. Could you repeat that?
Yeah, just a second. I need to get her microphone back unmuted here. She asked, I'm going to have to paraphrase Lysandra, I'm sorry. She asked, With Armada, what are the limitations? Can it go everywhere? Can it withstand every temperature? Can it withstand any weather? What are its limitations?
Great question, Lysandra. Really good question, and one that keeps a lot of people at Ocean Infinity very busy. So there are two things that really sort of limit that. So one of them is communications. So we use satellite communications, which effectively allows us to communicate with the robotic ships anywhere on the planet. So from our remote operations center, we've got two of those, one in the UK and one in the States. We can link to the ships via satellites. Now, there are a few black spots right at the far North Pole and the far South Pole. There isn't satellite coverage, but there's very thick ice, so we can't actually send the boats there anyway. So communications-wise, we've got most of the planet covered. When it comes to restrictions from other things, there are certain times of the year, in particular areas of the world, where there's incredibly big waves, incredibly terrible storms, and we typically try and plan not to send the ships there at that time of year. And then there are some areas where there's very, very thick ice and huge icebergs. And again, those would be areas we typically plan not to send the robot boats. But in terms of temperatures, the systems are designed such that they can operate in a really wide range of temperatures. They have cooling and heating systems to allow them to operate in most latitudes on the planet. So great question, but with modern communications and good engineering design, you can go to most places.
All right, fantastic question. Let's move over to Lydia. Lydia, do you have a question you'd like to ask Dan or Ollie?
Yeah. I want to say, are underwater routes important?
Can you say that one more time, please?
Are underwater routes important?
I'm sorry, there's just a little bit of a skip.
Are underwater routes important?
Important. I think underwater robots are very important, if that's what you asked. Is that right, Lydia? Your line broke up a little bit. You're asking if they're important. I think incredibly important. There's so much, as Ollie said, that we still need to learn about the oceans, that doing it from conventional ships with people on board, it's just not possible to cover that much of the ocean. It's either incredibly expensive or very, very slow. When we use robots, we can cover the area very, very quickly, much more efficiently, and we get much better data. So yeah, they're incredibly important, and it doesn't matter whether you work for an offshore energy company or a science, biology, chemistry, subsea company. They're incredibly important bits of tech. So yeah, good question. They're important.
Yeah, thank you, Lydia, for that great question. Let's go over to Alexa. Alexa, do you have a question you want to ask?
Yes. What has been the most fascinating experience with this technology?
I think there's a number of different ways of answering that question, and it probably depends on the part of the whole thing that you're interested in. For me, probably the most exciting thing I've ever been involved in was when we found the wreckage of an Argentinian submarine. And the reason that was important was because the families of the poor people who died on that submarine were desperate to know what had happened and find out, where their families had gone. And we were able to do that for them. And that, for me, as an experience and what we can do with robots, and actually, answers the question, why are they important? Because we were able to do that and help those poor people have that understanding. And that, for me, is what I love, is the end piece. What can we do with the information that we've got? But I'm sure Dan would answer the question with reference to actually some really clever technology that he's been involved in creating. So I'll let him kind of answer it from that sense.
Put me on the spot. I guess I got involved in a really interesting project with some scientists that we were trying to work out how whales and dolphins migrated from one area to another. And over time, research had shown that if you went out with a big noisy ship and tried to listen for these whales and dolphins, you might interfere with their behavior, and you didn't get a true record of where they were migrating or how they behaved. So we fitted microphones to a robotic boat, a very, very quiet one, and we sent it out into the Atlantic and listened for these whales and dolphins. And we found some migratory patterns that people hadn't necessarily recognized happened before. So we helped scientists understand exactly how these really important and endangered animals in some cases behave. So that was a fascinating one for me. It was doing something that couldn't be done any other way. So I think you'll find anyone involved with marine robots would have countless stories of cool things they've done with them. It's a fun thing to do, no doubt about it.
All right, fantastic. Thanks for the great question. I want to go to Benjamin next. Benjamin, do you have a question you'd like to ask?
Yes. Let's say a student like me would like to research this professionally when I'm older. What are the steps I would need to take to become a marine biologist?
So to become a marine biologist, I can't say I could answer that with exact accuracy, not being one. I'm a clanky mechanical type of engineer, but I'm lucky to work with marine biologists. And I guess all of them started off, this sounds cheesy, but all of them started off by working hard at school. They're definitely all people that know how to study, know how to research things, know how to pay attention. They're interested in the detail. So yeah, they're people that care and work hard. And then I think there's a huge range of routes into that particular topic. One would be, if appropriate, maybe you could go and get some sort of degree or higher diploma to do it. Another one is apply for work experience, join one of the organizations that does that type of work and work hard and work your way up. Anyone can get into that profession if they work hard. It's a great chance to travel. I've always been jealous of the marine biologists, that they're always the ones with the suntans and into surfing and get to travel to lots of cool places. So I think that would be a great choice of career, but yeah, work hard now.
That is a really good question, and I direct you to the Woodell Sea expedition that we did together back in last winter, where a bunch of scientists and technicians and people of all different backgrounds and professions work together to tackle a bunch of really serious logistical and scientific and exploration related goals. So you can really be a part of the marine research world through a lot of different channels. I want to take a couple questions from our live stream chat too. There's certainly no shortage, and I love all the great participation from everybody. I'm sorry if we're slow to get to your questions, but we'll get to as many as we can. We had a couple questions about interactions between marine robots and animals. And Dan, I think you touched on that a little bit with one of the surveys that you worked on. Can either of you share any other examples where either your robots encountered something unexpected in the animal world, or if you saw something particularly cool underwater from the animal world?
One of the things I always find is really exciting, again, you know, like that film we showed, is where you notice in the corner there's like a really cool crab, and you think, I'm looking for a shipwreck, but actually there's a little crab guy. Or you see plant life. And I remember one project we did was in the North Atlantic, which must have been nearly 3 miles below the surface of the sea, where there should have been no life. And there was this amazing little group of plants that were growing in this kind of shipwreck. And to see this, where you think, but there shouldn't be anything there, was absolutely incredible. Really, really amazing.
Wow.
But on the whole, I think we're quite lucky in the sense that we're able to put our robots into the ocean and we don't disturb the animals and the animals don't disturb us. So I think on the whole, the answer is we don't see that many. I've certainly never seen a whale or a dolphin swimming by when we're down there with the video.
All right, great. Well, we are running over on time already. We have had such a fantastic conversation. I want to finish this live stream the way we finish all of our show and tell live streams, and that is to ask Ollie and Dan, after the COVID-19 pandemic is over and we're all back and moving around the world again, what will be your next global adventure?
So I'll go
I'm
first.
going to Texas.
So my next one, I'm very much looking forward to the opportunity to travel up to the very tip of Norway. So north of Norway, we're having some of our robotic ships built there. And in Norway, there are some very, very deep fjords. So these are sort of inland seas, incredibly deep water, very cold, and lots of snow on the mountains. And we're going to be running one of these robotic ships with an ROV connected to it. So I'm looking forward to a trip to northern Norway when we can get back on an aeroplane and travel safely. Hopefully that's fairly soon.
Fantastic. And Ollie, you're going to Texas?
Yeah, I love Texas. So I'm going to Austin in Texas.
All right. Sounds great. Before we go, I want to give all of our students who are on camera with us today a chance to say goodbye and thank you to our special guest today. So I'm going to unmute you all and go ahead.
Thank you.
Yeah, thank you.
Thank you.
Thank you.
Thank you so much.
Thank you for all your questions. Really good.
Nice to talk to you all, and I hope everyone watching found that useful.
Awesome. Well, that was a lot of fun. That 40 minutes has gone by so fast. I want to thank Ollie and Dan for your time today. Thank you to our entire YouTube live stream audience for joining us. We have an amazing lineup of STEM-related live stream events still to go this week. Tomorrow, we're going to be talking with explorer and researcher Mai Fami about her expedition to Madagascar's Lost Forest. And in the afternoon, we're talking with Kevin Hand, who's NASA's Deputy Chief Scientist for Solar System Exploration, about his search for life on other planets. So it's an amazing lineup. You absolutely won't want to miss either of those events. Please check out the complete calendar of events at athome.reachtheworld, and we'll see you all next time.
Thank you.
Great.
Thank you.